Thanks for coming. Welcome to my talk. My name is Wolf Schlegel. I'm developer at ThoughtWorks. And this talk is about kind of building microservices in the cloud. And it summarizes experiences we have made in a project last year. So I spent 15 months with AutoScout24, based in Munich in Germany, building microservices in the cloud. And what we learned during that period of time, I would like to tell you about in this session. So what are we going to look at? We've roughly organized it into 4 stages. So first I would like to give you a brief introduction into what AutoScout24 are actually doing. And secondly, why are they shifting gears? Why did they decide to do what we did? And then have a look at kind of technical stuff, how we build our services. And last but not least, looking at the peopleware. How did we organize ourselves? How do teams look like at AutoScout today? So today, no hidden agenda. When we do this talk in Germany, the hidden agenda is all of us are hiring. And so I'm Wolf, and Christian Deger is not here today. He is coding architect at AutoScout, and we've done this talk a few times last year throughout Europe. So, who are AutoScout24? AutoScout24 are a business who are offering and operating a platform where you can advertise a car you want to sell. You can either do this as a professional dealer, or you can do it as a private person. So you put your car onto the platform, put in some description, say this is my Volkswagen, don't like it anymore, the diesel is a bit smelly, but got a nice color and not too many miles on the clock. And then people can look at that platform and search for cars, and if they're interested, they would get in touch with you. And this is effectively the core business AutoScout are providing. Once I am contacted by someone interested in buying that car, AutoScout effectively are out of the deal. So they just kind of initiate the contact. So they operate a marketplace. And the key concept on that marketplace is what we see in the center on this slide. It is the classified. Classified means this is the advert describing the car. And we've got different functionalities or different functions organized around the classified. So we mentioned we do have private sellers creating classifieds. We've got dealers. Dealers have kind of stock management. They also create classifieds. Dealers want to have reports, how their classifieds are doing. And there are kind of additional products and that are put onto the platform. And so on the left-hand side here, we effectively see how classifieds come into existence. We could also describe it as this is the writing side of their business. On the right-hand side, we see how classifieds are being consumed when we look at the platform. So we can search for classifieds, we can create a watch list where I express interest and I want to observe a classified, how it evolves over time. And I can go into details and look at a particular classified. So from a list view, I can kind of zoom in and say, this Volkswagen, I really want to look at it in more detail. This is what AutoScout are doing. It's all about classifieds. And AutoScout IT is about quite old, and it used to be quite old last year. And the baseline is highly optimized, supported growth of the business for kind of more than 6 years. And it was based on a Microsoft-oriented stack and operated in their own data centers. And AutoScout themselves, they are truly adhering to kind of agile and lean principles. And it was kind of, it was working well. And then something happened. AutoScout got a new CEO. And this is Greg Ellis. And the new CEO asked kind of one question, which is, are you ready for the future? And they looked at kind of what products offerings are they doing? Do they have ideas kind of evolve those product offerings? They looked a little bit at the tech stack, but this tech stack was more kind of the boring stuff. And the key question they asked themselves is, do you attract talent? And when we look at the tech stack we just described briefly before, the kind of Microsoft-based and running in their own data center, it was all working well and functioning, but not super exciting. And in particular, AutoScout in Munich were facing a situation where There is a marketplace for .NET-based or developers fluent in .NET. They tended to come from kind of banks or insurance companies. They tended not to know about kind of web development, so AutoScout could train those people. But more importantly, if you compare the ecosystem around .NET and Microsoft software development and compare it to, say, the JVM Linux world, what you find is this wheel, kind of technology, excitement, community, talent, is much larger in the JVM Linux world. So they decided to kind of move on to a different technology, to attract talent, to be ready for the future. That's kind of the short story. So AutoScout decided to start a project called Project Tatsu. Tatsu is a Japanese dragon, and it means flying beast. So there's also a roller coaster in the United States, which is called Tatsu. So this name was chosen for kind of two purposes, so it represents two things. Once, we are not afraid of implementing the change we're going to look at in more detail just in a minute. But also at times it felt a bit like a roller coaster journey. So what decided AutoScout to do when shifting from the existing tech stack to the new tech stack? We were facing 5 challenges. So the existing platform, the existing system was rather monolithic. And so we wanted to break down that monolith into microservices. At the same time, we wanted to move away from operating their own data center and move on to AWS, so operate the new services in the cloud. The underlying tech stack changed from .NET operated on Windows to JVM operated on Linux. And on the people side, traditionally AutoScout had developers sitting here, operations in the data center sitting over there, and they wanted to move away from that model and kind of operate DevOps, a DevOps culture. And you may have listened to James in his talk just before this one. He talked a lot about how Conway's law applies in these situations, and you may recognize some of kind of his musings in this talk. And again, last but not least, it's important to involve product people in that transition. So it started triggered by IT, but unless you get product people on board, it's not going to be an easy journey. And we're going to learn a little bit about that as well. From a technical viewpoint, the transformation, the idea was roughly like that. So take the monolith, which we see. This is the large chunk in stage number 1. This is based on .NET. The monolith had been kind of taken apart, but also replicated into larger slices, which we see sitting next to the big square, the big rectangle over there. So take a feature, take it out there, out of the monolith, create new services, and repeat until the monolith is eaten up and you've got all the new services there up and running. What's important here is that when taking a chunk out of the existing monolith, it should be a full feature, or better, as James put it, it should be a full product. And the chunk we started with, we chose to select is what was pretty easy. So it's the watch list we have seen before. So you can just earmark classifieds, I'm interested in you. There was a reason for picking that one, because when starting this transformation, a lot of things were new. It was a new programming language, it was a new operation environment. So in the first 3 to 6 months, we had to learn, or the teams working at AutoScout had to learn many new technologies. We worked in mixed teams. So we had developers from AutoScout, and we injected some developers from ThoughtWorks. And the idea was, start with a single team, build the first service, and then start with another service, and grow in number of teams. So in the first quarter, single team. Second quarter, we had 2 teams, and third quarter, we had 4 teams. Then we took a bit of a break. And the goal was to kind of transition all the teams who were developing on the incumbent tech stack into the new tech stack. And we as ThoughtWorks helped by coaching and by working hands-on in the team, so cutting some code. So it chose the first feature, the watch list. This became the first service. And one important paradigm was the microservices we started developing should be self-contained. So they should contain their own user interface. And we're going to look at that in more detail at a later stage. While implementing this transformation, the task was change the wheels while driving. So this is easy. So in the pit stop, the race car stops and then they change the wheels. But for AutoScout24, it meant that the existing platform had to be kept up and running, had to be maintained while the new services were being built. And as we all like working software, we wanted to bring those new services into production. So we had to kind of integrate the incumbent platform, the cache stack, as it is being called, with the new services. So change the wheels while driving. Right. So governing all of this and kind of floating all of that were kind of a bunch of principles and ideas. And these are the principles we were using last year. And when I'm talking about this slide, more often than not, people start taking pictures. Difficult for me to spot right now because it's pretty dark in the audience. There's a warning. So first, this is not top secret. Feel free to take a picture. However, the important thing is that we debated about this at AutoScout. And if you want to make a similar journey compared to AutoScout, chances are you're going to need a similar set of principles who are guiding you. But the important stuff is you need to find your own. So we started with kind of strategic goals, kind of what does business want? And this is the what as opposed to the how, as James described in his earlier talk. We derived a bunch of architectural principles and then also derived kind of design and delivery principles. I'm not going to walk through all of these. That would be way too much for this talk. And we're going to zoom in to a few of them. And the first one, we wanted to organize whatever we are doing around business capabilities, kind of thinking in terms of products, not in terms of projects. And following the domain and the bounded context was super important. This helped us kind of cutting the monolith into pieces and identifying the microservices. We always follow the domain, and we had kind of domain models on the wall. And if we wouldn't understand why this belongs to one domain or the other, we wouldn't kind of move on and define the service boundaries until we understood that. The team setup, as I mentioned before, was moving to DevOps teams, but a name we like much more is the you build it, you run it team. So in this team, cross-functional team, you've got the product owner, you've got business analysts, you've got QA people, and you've got a bunch of developers or engineers, as AutoScout likes to call them. And these engineers came from different backgrounds. So you had the engineers that were developers before, and you had engineers that were doing operations works. And the goal is that teams building services to support a particular product or to define a particular product, they would also operate these services. And so they would get the pager and they would need to get up at 3 o'clock in the morning if things go wrong. Another principle was be bold. And this is where Christian Deger, my partner in crime at AutoScout, he liked to say, well, be bold, but don't be stupid. So an example, at some stage, I think it was in the second quarter along the journey of Tatsu, we decided to kind of upgrade and use Java 8 and no longer Java 7. And traditionally, the operations people would have kind of thought about this very hard and say, what could go wrong and how can we ensure that services are up and running and are in production. And so we had a discussion around that. What do we need to do? I mean, to be honest, at that time, most of the new stuff was not yet customer-facing, so it was kind of easy. But at some point, someone cut the discussion and say, hey, you know what, why don't we just try deployment? Why don't we just use Java 8 as opposed to Java 7 on the underlying EC2 nodes and see what happens? And we're going to have a look at this boldness a little bit in more detail later on, and it just worked like a charm. So we were not stupid. We had thought about, okay, what could go wrong, and do we have mechanisms in place that would protect us if things go wrong? But we didn't over-engineer and kind of decided, well, we need to have all kinds of contingency measures. And this effectively is about a change where you optimize for mean time to recovery. In the old world, AutoScout optimized for mean time between failure. So you put a lot of effort in to have as few failures as possible. But in the new world, you kind of accept the possibility of failures, and you want to be able to recover soon, and you want to know about the failure. Another principle was kind of distinction between macro and micro architecture. And macro architecture is the stuff that's given, that's not negotiable. It is being decided. Teams have their say when deciding about macro architecture, but effectively some of this drops out of the sky, and it's kind of, there's no debate around that. For example, AutoScout decided to run the new services on AWS as a cloud-based platform. So all this stuff we did was based on AWS. There was no debate, well, should we have a layer of abstraction? Should we think about what if we want to move away from AWS? No, that was a given. Similarly, the use of JVM languages was a given. So a team could decide which language to use. We use Scala, by the way, and kind of most teams stuck to Scala. But with good reason, a team could decide to build their service using a different JVM language. Also, kind of things around kind of monitoring, or in particular security, they tended to fall into the macro architecture, where I say teams, we need to have a common approach to security. It's not only inefficient, but it's risky if teams to decide to kind of cook their own security soup. So this tended to be part of the macro architecture as well. In the micro architecture, teams could decide what they wanted to use. So they could choose, as I mentioned, the JVM language, or if they needed a persistent store for their service, they could choose which store to use. And there tended to be a pecking order where you say, well, I need some support for, say, persistence. So do I find it, and say I already know I want to know SQL data store. So first stop is, do Amazon, do AWS provide the respective service? And yes, they do DynamoDB. And if, say, a team says, oh, I need a relational data store, then again, first you would look at AWS, what do they provide? If they do not have a service that is fitting the bill, next we would go to some other service provider. And if that doesn't work, we would go for open source and kind of hand-roll stuff and operate it ourselves. If that doesn't work, we would go for kind of paid software and get a license of some stuff. That was the typical pecking order when deciding about the tech stack. The last one is about shared nothing. And this turned out to be a topic that was really debated in mid-flight, and it really surprised us. So maybe before going into why did we have a debate and what was it about, we have a look at what did we mean by shared nothing. So shared nothing comes from the notion of, if we share things, if different teams share stuff, we create dependencies. If we create dependencies, teams can move slower, so we slow stuff down. So ideally, we would say all the teams, they are utterly independent. The services should be independently deployed, and everybody's happy. And when you think about it, you say, well, but there are some characteristics, some concerns, which may be more important than sharing nothing. And this is, in our case, availability. So if availability is affected by sharing nothing, I would rather have high availability than 100% shared nothing. And the way these two ideas or these two concepts are connected is, if you share nothing, each team has their own tech stack, their way of deploying, their way of monitoring and of logging, and their own kind of security implementation, and things go wrong. It's hard to rectify things because you need to understand all those 10 different approaches you may have. So we say, well, in the interest of availability, we should all have the same approach to logging. So if I look at my Kibana dashboards, I can see the whole picture and don't need to look at 5 places to understand how are 5 services interacting. So this is where we said availability beats shared nothing. So we agree on kind of shared infrastructure. Similarly for security. While doing so we had mandatory offerings regarding the infrastructure. And we also had convenience offerings. And one of those was the deployment or delivery pipeline we built up. So we used GoCD for continuous delivery, but teams were free to implement their own continuous delivery pipeline, and it was entirely up to them. So this is what we labeled as convenience offering. Very important for convenience offerings as well as for the other stuff. If it is shared, there's always the risk of side effects. So we learned this the hard way when building the first dashboards, kind of different teams shared dashboards. And at one occasion, we mixed up metrics. So one dashboard was red, but the underlying value belonged to the other team. And this told us, well, we should kind of keep things separate. And generally, I mentioned before with the Java 8 discussion, we preferred fast local decisions, so we didn't have grand committees. But also, we try to respect family ties. And that relates to a sister company, Immobilien Scout, and they are dealing with real estate, and they're also running their services based on JVM in the cloud. So we got together and say, hey, how are you doing things, and how are we doing things? We also kind of set up a bunch of rules or guidelines how to share or how not to share. And this is when the debate became really heated. So the first 2 quarters, we only had one, and then eventually we had 2 teams, and it was pretty familiar. Everybody knew what was going on. And the lesson learned when we made the transition from 2 to 4 teams was people who had worked there for 3 or 6 months took things for granted. So we didn't spend enough effort in kind of conveying the principles we've seen before. We just started taking them for granted. And new developers and engineers joined the program. So we had kind of doubled the amount of developers. And some said, now hang on, this share nothing thing doesn't sound good to me. In my world, if I'm building a service and I need a component doing, say, some conversion or number conversion, whatever, I like to make this a proper library and someone else can use the library, and I'm proud as a developer because I developed stuff that's useful to other people. And we said, no, we don't want to do that at all because this is implying dependencies and slowing us down. And then they said, yeah, but we're all using the same underlying open source stuff, so we are coupled anyway. And there was a heated debate. And when a team needed a particular feature, it could be that they said, oh, let's build this library first, and then we start using it for the feature. And we said, well, okay, so if you really, really want to share your stuff, one of the rules is use over reuse. So the thing you believe is useful for everybody else, start using it and use it in production. And only if and when you find it's really a good thing, start thinking about reusing it. And before reusing, kind of harden it. So build in the feedback you collected while it's in production. And so we had kind of the first stage of sharing was copy and paste. And that sounds horrible. This is kind of what you learn at university, what your mates are telling you. It's horrible if you copy and paste, you end up with kind of variations of the same code scattered all over your possibly monolithic system, and it's just in a mess if you want to change it. However, we are talking about microservices. And for example, when using DynamoDB as persistent store for services, NoSQL database, the scope we used it typically was a single table for a single service, as opposed to kind of a large relational schema underneath a monolith. And the code we used to kind of read from and write to a DynamoDB table was maybe 5 classes, possibly less, plus the respective test classes. So we were confident to copy and paste that code into new services. And then we observed this code base, and we copied the tests as well. And then it may evolve into different directions for different services. And for example, for the the code we wrote for logging, I think it took us about a year to understand, okay, this is the common theme, and then we pulled it out, made it like internal open source, and then it became a library. And that library was pulled by teams, so it wasn't imposed on teams. And this is how we approached sharing and not sharing. Another question which was kind of intensely discussed at the beginning was how many environments do we want to operate? So as I mentioned, everything is running on AWS. So technically, if you can spin up one environment, you can easily spin up 10 environments. We automated everything, so we could spin up environments from our delivery pipeline. And traditionally, you would have seen a setup like this. So kind of engineers working on their machine, so my local development environment. Then you've got a continuous integration environment where artifacts are being built and tested. You've got a dev environment where they are deployed for the first time. You may have a staging environment where you are trying out new things you're about to release to production. So you've got these 5 stages. And the challenge here is that you've got different components in different versions. And so on production, we've got version 1 of the blue component or the blue service and version 4 of the yellow one. And so pending is version 2 of the blue one and 5 of the yellow one. Now, this is how AutoScout have worked traditionally in their own data center with the cache stack software. However, what they found historically, this is empirical kind of evidence, what they found, they put quite some effort in running staging and testing the software on staging, but the important bugs were not found on staging, but they just kind of came up on production. So the question was, what's the benefit? What do we get out of operating staging? And now you take this times number of microservices. So we've got different teams, and each team would need to operate their own kind of dev and staging environment to be independent of the other teams, because each team would say, well, this is the mix of services and their versions on production right now, and I want to test the next version of mine against this one. And while they're doing so, some other team is testing the next version of their service. So the mix each team would operate on staging is kind of flawed because it doesn't really represent what's going to be on prod the very next moment. And while this is technically easy to operate, you just need to throw money into the AWS machine, we decided just not to do it. And so this was our setup. Engineers, local development environment, CI building the artifacts, and then we had 2 environments. One is called dev, the other one is called prod. And the rules of the game were deploy stuff to dev, but on dev, services do not integrate with other services. We had no integration tests in the sense that on dev, my service is poking your service, and we see if everything goes well. The first time services technically integrate is on prod. And this sounds quite bold or possibly stupid. So how could you do that? How could you not have running tests in staging environments? Now, we had a number of measures that allowed us to do so. And again, this is just taking out staging because we learned staging doesn't give us much value. And things that helped us doing this is on AWS, when you want to spin up a new version of a service, what happens in slow motion is you've got, say, 5 EC2 nodes hosting the old version, and you want to deploy the next version, so one node spins up and is added to the load balancer, but only after the service has raised his hand and say new version is healthy. So the load balancer is kind of running health checks, is observing the health of a service. So if you were to deploy to prod and the new version says I'm unhappy, I'm unhealthy, developers would see a red tile on their dashboard, but consumers kind of using the services on prod, they wouldn't notice anything, because AWS would have pulled the plug and stopped the release of the new services. To integrate or to have a substitute for the seemingly missing integration testing, we use consumer-driven contracts, where service A, depending on service B, provides the team developing service B with a bunch of executable tests that are run as part of the build pipeline. So whenever service B changed their API or their interfaces, and that would break service A, they are notified by these tests being run. And similarly, Team A would need to run some mocks of service B, but that's I could spend the whole session on that topic. So just take away consumer-driven contracts help you here. Also, we did shadow traffic. Shadow traffic effectively allowed us to eliminate the need of performance testing. So the idea of shadow traffic is, I've got a new service, I have deployed it to production many times, but it was never visible to real consumers or users. So what we are doing is, in the example of the watch list, the old watch list and the new watch list coexist, and I just redirect traffic. Whenever someone wants to watch the watch list, I just create a respective request to the new service and see what happens. Can it handle the load? And the first time we did this, the new watch list just couldn't cope with it. So we broke it by using shadow traffic, but we fixed it easily. And lesson learned is don't do performance testing if you can rely on shadow traffic. And that became something mandatory for all the services to be released. I skipped the smoke tests or canary releases in the interest of time because we're a bit slow right now. So another aspect, event sourcing and data pumps. So we've got the old system. And if you recall the image where classifieds are being created by the writing side, this all still happened in the cache stack. So classifieds were created and eventually existed in the underlying Oracle database. Now the new services needed information about classifieds. How would they get that? Golden rule, new services should never go back to the data center and say query data, because if you do that, eventually you've got all the features of your products migrated to the new platform, but you've got hell of a lot of dependencies into the old platform and you simply can't take it off. So we established a one-way data highway. So information we needed about classifieds was to be propagated from the cache stack into the cloud. And we used event sourcing as an approach to do that. So the first service we built where we applied this data pump, as we called it, was about getting classified data into the watch list service, because when you imagine a watch list page, you've got a list of classifieds or a list of cars in there, and you want to see some base information, kind of what is the make, what's the model, you want to see a picture, and what's the mileage. So the watch list needs a subset of the information contained by a classified. And we started thinking about, well, how do we want to achieve this? How do we want to implement the data pump, and how do we want to store the information in the cloud? And what we see here on this slide is a combination of different queuing and streaming and storing technologies offered by AWS. So we don't go through these in all detail, but what happened here is within a fortnight, we tried all these combinations. And this is really nice about development in the cloud. So you just throw in some money, and it's no serious money, and you say, what if we try queuing and S3, which is the first combination? So you just cut some code, write some tests, and you test against the real thing. Then you say, they've got this kinesis streaming thing, what if we try that? And you can start immediately, as opposed to an approach where you operate stuff in your own data center, and it may take you 3 months or up to half a year to get your enterprise service bus software installed. This is what I've seen in other projects. Super, super fast if you develop against the cloud. And so we ended up with fast forwarding, doing all of this in DynamoDB. And another lesson learned, DynamoDB is a database. So the former operations people at AutoScout said, well, you know what, whenever we operate our Oracle database, we protect it. So we put some proxies in front of that, and we've got this kind of DMZ, and let's do that for DynamoDB as well. We said, yes, let's do that. And the next morning, someone observed that this does not apply to DynamoDB because it is a hosted service. It's a global service provided by AWS. You don't install your own DynamoDB that you can somehow protect. The only way to protect this is don't give away your credentials. And this was kind of one of these lesson learned when starting to work in the cloud, and things are just different compared to the way we worked traditionally. Let's have a quick look at front-end integration. So when describing how we cut down the monoliths and kind of sliced and diced it into services, I mentioned that we wanted our services to be self-contained, so they have their own user interface. And so you can have all these services sitting next to each other, but still somehow you need to integrate the stuff these services are providing into the single page an end user or customer is looking at. And there are two approaches to that. One is to operate headless microservice, say, okay, all the services just give us an API and they give us data and they give us some JSON objects about the respective domain they're dealing with. And then you've got a thick layer, which is the UI monolith sitting on top of all these services. And again, you introduce dependencies. So there was a heated debate which approach to use. And there's no clear-cut argument. And eventually, the teams agreed that let's try the self-contained services over the UI monoliths, because in the monoliths, when you want to change things, teams need to kind of talk to each other, which in itself is not a bad thing, but it would just slow the teams down. So you still need to know, well, how can you accomplish getting stuff onto one page? And this is what front-end integration is about. And this is how it looked, roughly. So imagine a request for a page coming in. So first we had kind of AWS CloudFront sitting on top. And CloudFront took decisions like, this is a page which is still served by the old system, so was redirected to the data center running the cache stack. Oh, no, this is one of the new pages. So it goes into Jigsaw, which is the name for the service we built to deal with front-end integration. And in Jigsaw, we would operate in Nginx, and we used an approach called edge-side include. So you ask for a page, and some service is returning the page. So Jigsaw knows, I need the watch list page, so I'm calling the watch list component, and the watch list component may return a page. And that page contains references to snippets provided by other services. And these are being resolved by Jigsaw. So Jigsaw would know, here they want some advertising in there, or they want something else which doesn't belong to the watchlist service, and would just talk to the other services A, B, and C, and would get all the partial results or the partial pages and aggregate them and return the result. Now there's one challenge around that, and this is kind of fragmentation of CSS and JavaScript. And what we were using in here is what's called a page speed module. And this is really neat. What it is doing, after having talked to all four services and having these CSS and JavaScript fragments, the page speed module is rearranging those. So you would have just one CSS and just one JavaScript at the end of the page. And combined with caching, this really worked well for us and kind of super fast. Right, moving on from technology to peopleware. How did we build the teams and how did autonomous teams look like? So as I mentioned before, teams covered all kind of capabilities. So cross-functional teams, product owner, business analysis, QA, and the engineers and the developers. And one thing to look out for when you set up such a team and you're doing this for the first time, or the given team may be working in this model for the first time, is do not fall back into old behaviors, or you beware of the Mandelbrot teams. So Mandelbrots are these kind of fractal images. You zoom in and they just look like they looked before. And one of these kind of Mandelbrot effects we could see is before AutoScout had developers sitting here, operations over there, you get a bunch of ops people and a bunch of devs kind of brand them as engineers, put them together, and you may find that the former ops people like to work on the infrastructure stories, and the former dev people like to do all the development work. And then you should intervene and say, sorry, don't like this kind of mix. So we did a lot of pairing. Pairing was the kind of standard model, and then we would have a former ops with a former non-ops person pairing, and we would just kind of keep an eye on it and say, don't always have the same old guys working on the same stuff. We did a lot of show and tell sessions, where kind of to disseminate knowledge within the teams, and that helped. So we were conscious about that effect kicking in. So whenever we spotted it, we acted accordingly. So the autonomous teams were supposed to run the services, so they were on pager duty, getting up at 3 o'clock in the morning. And initially, people were just kind of scared or just of uncertain, what do I do at 3 o'clock in the morning? So we did some dry runs, and we kind of compiled run books, which had kind of, if you are in this situation, do these 3 steps. And we had to think about how do we set up the team rota. And as James mentioned, contracts had to be rewritten, because normally as a developer with your kind of 9 to 5 job, you wouldn't expect to be working on the weekend. So there is a legal side to that. In Germany, it's very clearly described and regulated, so you may want to look into the legal aspects of that as well. And we had to decide for kind of a software how to notify people and how to set up rota. And this is where the model kicked in. Didn't really find a good service at the time on AWS, helping us with the kind of rota for operation service, and we used OpsGenie for that one. Next one in the teams, kind of watch out for broken Windows stuff. If you kind of fall back into old behaviors, and the team may get used to that. So as soon as the first window is broken, act on that. We tried part-time ops for a while, but that didn't work well. So the idea was having ops people in the DevOps teams, but initially they were tied, so they had responsibilities in the old platform, and we experimented with a model where they would rotate on a weekly basis. So 2 ops people would join the new Tatsu team for week 1, and they would swap out in week 2 and then come in again on week 3 and so forth. But that didn't work at all. So there was lack of a lot of handover stuff, and stories were kind of left unfinished, so we couldn't recommend that one. And then the ideal team member is what we like to call a T-shape. So you kind of got a broad knowledge, a rough knowledge about everything, and you've got kind of specialized skill around particular aspects. And that's fine. So where we found not all T-shapes are the same. You still find preferences. Someone prefers UI work and doing all the CSS and pixel pushing and fine-tuning, and someone prefers working on the back end. What we wanted to avoid is that these are kind of really embedded specialities that people would never look left or right and do stuff else. So it's okay to have different interests in different T-shapes, but again, knowledge should be spread across all the team. Looking at the kind of underlying infrastructure we talked about very early on, where we say we do have some shared infrastructure. The model we operated here was called the infrastructure guild. And it worked like that. So the guild existed as a virtual body, if you like. So you've got 5 teams, and from each team you would have 1 or 2 members attending the guild meeting. And they would agree on things to do. So as teams have their backlog and their stories for the product they are building, the infrastructure guild would say, these are the things that need to be done in infrastructure land. They would also kind of share learnings, how to build infrastructure in this guild. However, important stuff, they delegate implementation back to the teams. There was no work being done in the infrastructure guild. We felt that is important because each person, each engineer should have one home, and that should be the team the engineer is working on. And having infrastructure guild that are actually doing hands-on work felt like, we've got 2 homes, and didn't feel right to us. Ideally, the infrastructure guild should have an empty backlog, so all the infrastructure stuff is being done. This is where you find the usual kind of conflict of interest between, okay, so I've got my team, I've got my engineers, what should they do? Should they work on features or should they work on cross-functionals, sometimes called non-functionals? And at times, product owners say, oh, no, you do all the features, just forget about the cross-functionals. And we kept an eye on that. Because unless the work delegated back into the teams is done, we don't get the infrastructure we need. So rule of thumb is, in a team, over a period of 3 months, on average, 20 to 30% of your capacity goes into infrastructure work. And this is likely to go down the longer the services are running. But initially, you would invest possibly more than that into infrastructure. Another fundamental question was, do we want to have an infrastructure product team? So a team or a couple of teams dedicated to building infrastructure. We started without those. So we started having 1, 2, and later 4, and then 6 autonomous teams, and they built the infrastructure. And in the guild decided who's doing what. And we felt that there was a risk if we have the infrastructure product team from early on, all the ops people would go there, and there would be a lack of operational knowledge in the DevOps teams, which again implies they couldn't operate the services because they couldn't get up at 3 o'clock and fix them because they had never got their hands dirty building infrastructure. Also, infrastructure product teams may give you products or infrastructure you don't need. So we really wanted to have a very close feedback loop, like from a product view, from a service view, we need this kind of infrastructure, and this is the reason why we are building it. In the meantime, AutoScout have decided to have such an infrastructure product team. So one reason being, as the number of kind of teams increases, there is kind of less work to do. So let me put it differently. So if you spin up more and more product teams, you wouldn't need as many infrastructure product teams. Also, some of the former ops people, they didn't feel super happy working in a DevOps environment, and you need to find a home for those as well. But as I mentioned, there are aspects to look at. Right, that's my talk. And we have a couple of minutes left for questions, if you like. So I guess it's difficult for me to see you, so if you just start shouting your questions, I shall repeat them and hopefully answer them. Yeah. Right. So the question was, there are times we operated both environments still in the so the cache stack operated traditionally and in the cloud. The answer is the integration picture we have seen a few slides ago, where we say, actually it's 2 answers. One is the one-way route, so data goes from the data center into the cloud. And eventually, if you imagine a page being served by AutoScout, you can cut it into different components, and more of these components were served out of the cloud and less out of the data center. And this is an interesting aspect, interesting relation to how to get product people involved. Because initially, when you build new services, you don't have much to offer. You're still learning, and then you've got the first service, you're super proud. And product people, they say, I need this new feature on my product. Should I build it in the new tech stack? And don't see that coming very soon. So the old tech stack becomes a moving target. And you need to get buy-in from product management to say, okay, let's take this serious. Otherwise, you're building up something which is not being used. Yes, please. Yeah. Right. So the question is, what was our experience with respect to batch processing? So probably the closest thing we had around that one was if you imagine the kind of universe of AutoScout, you've got dealers creating classifieds, and so dealers could create kind of batches of classifieds, and they would need to be processed. So there are different aspects around that. One thing is services should be as independent as possible. So we set up a classified service in the cloud which contained the core classified data. And their batch processing became important in terms of how long does it take when a dealer creates, say, 1,000 new classifieds until they are available in the cloud. And this was looked after by the data pump. So the data pump was just kind of listen to changes or observe changes in the Oracle data store and just put information across. But then we had what we call the raw classified. So getting data from A to B is simple. But the new service offering or owning the raw classified wasn't useful to all the other services. So other services may need to enrich data. And we had quite some interesting discussions around how that should be achieved. Should it be kind of a centralized batch processing where I say new classifieds have come in. Now I need to affect those 5 changes to each classified. And this is where you need to get all these services and talk to the teams and say you need geolocation, and you need some assessment whether this is a fraudulent classified, and you need some other extra information put on top of your. And in the microarchitecture guild, we roughly sketched an approach how this could work. So what we wanted to avoid is that services kind of hard code enrichment of classifieds. So it had to be orchestrated in some way. So we had a range of solutions. We had kind of a very loosely coupled high-end solution where services just fire change events and automatically all the data gets in there. And on the other end of the spectrum, we had the hard-coded flow where we say this batch of data needs to undergo these changes. And we settled for kind of something in the middle. So we hard-coded the orchestration, but we were very careful to keep it flexible so that this model could be transformed into the other one. And as I mentioned, sticking to the domain, understanding the domain is super important. Don't cut your services and without obeying the domain, because then in the long run, it's all up and running, but you're going to hit a point where it's going to be very closely coupled. Yeah. Question is whether we observe performance issue around that one. No, not at the time I was working there. So I rolled off the project in the beginning of this year, but the key performance observation was around when we learned how useful shadow traffic was. And we monitored everything, and teams had their own dashboards, and they had their performance metrics of their services. Right. Yeah. Yes. So the question is, can I talk a little bit about the scale of the project? So we were talking in total about 10 to 12 teams to be kind of transitioned from the old tech stack to the new tech stack. Typical team size was 6 to 8 engineers, so 3 to 4 pairs, 1 product owner, and one QA. There was also some user experience capability, but that tended to be shared across teams, so you wouldn't have a full-time user experience person on a team. There was some contention around kind of the product ownership, and that again coming back to where we had to keep the old world and the new world running at the same time. So it was in the early days, it was not easy to get enough focus, enough attention from product owners, and this resulted in a phase in the second quarter. We built a lot of infrastructure, and we had a baroque logging infrastructure, which was partly driven by lack of business attention. And that's something to watch out for. So you want to get you want to get your products, you want to get the what into the new world. So you need to dedicate product owners to the new world. And it took, as I mentioned, so when new teams were formed, we worked kind of in quarters. So given a new quarter started, we decided to kind of get so many people into the new platform, into Tatsu. And we broke up the old teams initially. So we kind of reshuffled to have an appropriate mix of people who have been on the new platform for quite some time and the newbies. These were kind of the aspects we observed. We did that kind of breaking up and remixing for about 9 months. And then we realized this is kind of reshuffling the teams every 3 quarters is also affecting productivities of teams who are run in. And then we kind of implemented a different approach where we say, we build in new teams, so we inject wisdom and we inject people who have been around for a while into the new teams, but we want to try to minimize changes in the teams that are up and running. So to kind of, the trade-off was, is it about delivery or is it about learning? Initially it was about learning, so we reshuffled teams a lot so that everybody could learn a lot. But then after 9 months, we kind of reset focus, say delivery is as important, and while we need to support learning for new people, we need to keep delivering services and products. Right, so we are running over a little bit. Perhaps one more question, and otherwise I would call it a talk. Yeah. Yes. Right. Yeah. Yeah. So question was about HTML and CSS and how to isolate them. This is a good question. So what we did is we had a bunch of S-base CSS, or technically rather base SCSS, which was provided to all teams. And so teams would pull that from a repository and build their own SCSS on top of that. So technically the teams were still independent, and yes, you could be in a situation where different teams or different services, products would have different styles, but having the shared SCSS underneath would allow you to rectify that. And pretty soon, if you want to change color, was pretty straightforward to do that. But we didn't try to have an Uber base CSS that would cover everything. So teams would just pick the base stuff and build their own stuff on top of that. Right, okay. So that's it. That's my talk. And thank you very much. Enjoy your lunch.